Okay, let's continue the discussion of fundamental period. And from the discussion, we know that the fundamental period of a sine and cosine are 2 pi. So sine theta plus 2 pi is sine theta. You add one additional revolution, you do not change the stuff. And the cosine, you do not change the value. Theta plus 2 pi is cosine theta. And reciprocal will share the same fundamental period. So cosecant theta plus 2 pi is cosecant theta. And the secant of theta plus 2 pi is secant of theta. Okay, so these four trigonometric functions have the fundamental period 2 pi. And we have other two, tangent and cotangent. Let's check this graph and see the tangent cotangent. Remember, tangent of t is b over a. Keep this in mind. Tangent of t is b over a. So if this is a p with coordinate a and b, so tangent t is b over a. Let's get to the symmetric point. What is the symmetric point? Symmetric point p prime is negative a, negative b. Negative a, negative b, symmetric. And the corresponding property is that this is exactly pi. It's a straight circle, a straight angle is a pi. You add additional pi. So tangent t plus pi. You move to the this is t. T plus pi, you move to its symmetric point with respect to the origin. Then it is a negative b over negative a. Negative b over negative a is also b over a. Okay, so from this discussion we get tangent of theta plus pi is equal to tangent of theta. So tangent of theta, because of this ratio, it can cancel to negative sign. After you cancel to negative sign, after pi you repeat cotangent, same thing, because cotangent is a reciprocal of tangent. Okay, so this is the periodic properties. So here, this is periodic properties. This on page 557. Right? Okay, so now let's see the example. This example is similar. We had this similar example before. Find the exact, possibly we didn't discuss this pi for the tangent and cotangent. Exact value of each one. For example, a sine 420. Sine 420 is a sine 360 degrees plus 60 degrees. 360 is 2 pi. It's a 1 revolution, so it's a period. So it's a sine 60. Sine 60 is square root of 3 over 2. Okay, and b tangent 5 pi over 4. Tangent of 5 pi over 4 is pi plus pi over 4. Pi is a period, so it's tangent of pi over 4. Tangent of pi over 4 is 1. Okay, and cosine 11 pi over 4. Cosine 11 pi over 4 is cosine 3 pi over 4 plus 2 pi. So it's equal to cosine 3 pi over 4. 3 pi over 4, where is 3 pi over 4? It's a diagonal of the second quadrant. So it's equal to negative square root of 2 over 2. Okay, Okay, so this is the computation. How do you get this? How do you get this negative square root of 2 over 2? You find the reference angle. Okay, you find the reference angle. The reference angle is pi over 4. It's in the second quadrant. Negative cosine is negative, so you get a negative square root of 2. So you get negative cosine pi over 4. The reference angle approach. If you want to use the circle approach, remember that I said this is a diagonal of the second quadrant. So x, y coordinate have the same ops value. X, y coordinate have the same ops value. X is negative, y is positive. So x is equal to negative y. So you get a negative y squared plus y squared is equal to 1. So 2y squared is 1. So y squared is 1/2. So y is square root of 2 over 2. Because it's above x-axis, it's positive. Y is positive, so that's why you get positive square root. Yeah, you get a positive square root, and then x you get a negative square root. And cosine is x coordinate. So either works. This is a reference angle. This is the circular approach. A circular approach. Okay, in the circular approach, when we have this special position, we know that the relation between x and y. Of course, this method, it can only be applied for some special angles. If you have a so arbitrary angle, it's almost impossible for me to tell you how to determine the trig values. So far, we don't have enough tools to compute. Okay. Next. Let's see. Even odd property. This is also a very, very important stuff. Okay, let's see. Remember that we have the real number t. We have positive real number t, we go counterclockwise. We have p, a, b, this is positive t. If we have a negative t, we will go clockwise. But the length are the same. For t negative, you go opposite value of t negative. And since you move the same length, so the point is symmetric. So the point, they are both on the right side, so point is still A. One is on top, one is on bottom. So the coordinate is A and B, right? So this is negative t is negative, this is t is positive. And they keep the same A, keep the same x coordinate, but change the sign of y coordinate. So that's the observation. The observation gave us, you see, if we have a positive number, theta, we put a negative sign, it becomes a negative number. So you go along the clockwise orientation. Sign give you negative b, right? And the negative b, if you cover this negative sign, b is equal to theta. B, you go here, is equal to theta, is equal to sine t. Corresponds to theta, it is equal to sine t. So combine these two things, we get sine negative theta is equal to negative sine theta. You put a negative sign for two sides. Negative b is equal to negative sine theta. Negative b is equal to sine negative theta. So this is the even odd property. The sine function is an odd function. You have a negative sign, you can move it forward. Okay? So positive go up, negative go bottom. But since you move the same distance, those 2 points are symmetric about x-axis. Then if it is symmetric about x-axis, they share the same x-coordinate but different sign for the y-coordinate. And similarly, also from this picture, you see you go to positive, negative, the cosine negative theta is A, it's x-coordinate. The cosine of theta is also A. This pair of symmetric points have the same A, so we get cosine negative theta is equal to cosine theta. So sine is an odd function, cosine is an even function. Sine is odd, cosine is even. Right? Good. Now let's try to get the property for other 4 trig functions. Cosecant. Cosecant negative theta is 1 over sine negative theta. But we know sine is odd. You can move this negative sign forward. You can continue move this negative sign forward. And 1 over sine theta is cosecant theta. So it's negative cosecant theta. So what we have is that cosecant theta is also an odd function. Right? You see, you move this negative sign forward 1 step because of odd property, and then you move this negative sign from bottom to the front because of a quotient property. And then you recall the definition of a cosecant. And secant is 1 over cosine negative theta. Cosine is an even function. You just directly drop this negative sign. So secant of negative theta is just secant of theta. It's an even function. It's an even function. Now let's see the tangent. Tangent negative theta. Tangent is a sine over cosine. And the sine is an odd function. Cosine is an even function. So you lose 1 negative sign. You get a negative tangent theta, a negative sine over cosine. So tangent is odd. The reciprocal of odd function is also odd, so cotangent is odd function. In a similar way, you can go through this again. Okay, so that's an even odd properties. We have 6 trigonometric functions. Only secant, cosine are even. Other 4 trigonometric functions are odd. Only cosine and secant are even. All other functions are odd functions. Good. Even odd, we can easily drop the negative sign. Let's try the example. For example, we are looking for the value of sine negative 45 degrees. Because sine is an odd function, so it's negative sine 45. You move the negative sign forward. Sine 45, square root of 2 over 2. So it's negative square root of 2 over 2. B. Cosine negative pi. Cosine negative pi. Cosine is even function. It's equal to cosine pi. Recall that pi corresponds to the point here. This one is -1, 0. Cosine is related to the x coordinate. It's equal to -1. C, cotangent -3π/2. Cotangent is an odd function. You move negative sign forward, you get a cotangent 3π/2. 3π/2 is here. It's negative. And this one has, okay, so has a 0, -1 coordinate. And the cotangent is a over b. A over b is equal to 0. D, the tangent -37π/4. Wow. So negative sign, you move it forward. It's a tangent 37π/4. 37 is 36 plus 1, right? 36/4 is numpy, so it's tangent numpy plus π/4. Pi is a period. Numpy is can be dropped. You get a 9 revolution. 9 revolution, you simply remove the revolution. It's a tangent of π/4. Tangent π/4 is a 1. With negative sign, it's -1. Okay, so this is a discussion about even odd properties. So the this section is long. It contains many information, but basically it gives us a way to another way to understand the trigonometric functions, the circular function. So you can either use a circular approach or you can use the trigonometric approach, but it's always keep in mind y is related to sine, x is related to cosine. Okay, and then we studied the domain range of all 6 trigonometric functions. We also studied the even odd properties. So 6 trig functions, 2 even, 4 odd. Cosine, secant are even, other 4 trig functions are odd. Okay, so do the exercise, send me email if you have questions. Okay, we'll stop here. Thank you.